All right, this is question 5 from the 2012 test. We're talking about the weight of a bird, and they've given us, well, they're talking about the equation B, which is the weight of the bird at different times. We know at time 0, the bird weighed 20 grams. They've given us an equation, dB dt, so it's the rate of change of the weight of the bird with time. All right. Let y equals b of t be the solution to the differential equation. So in other words, they're just saying that this is the derivative. The dB dt is the derivative of the function b. Part A. I don't really feel like writing with pink, so let's go to black. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? So what I want you to notice is they're talking about the rate of change of the weight of the bird with respect to time. But notice that my independent variable in this question is not time. So they can't ask me a question that says, is the bird gaining weight at time 5 versus time 6? They have to talk about it in terms of the independent variable they've given me, which is weight. So when he weighs 40 grams, is it changing faster than or faster when he weighs 70 grams? So basically all we're going to do is just plug it in and see what we get. So dB dt equals 1/5 100 minus b evaluated at 40 is simply going to be 60 divided by 5 is 12, and that would be grams per day. And dB dt evaluated at 70 would be 30 divided by 5, which is 6 grams per day. So let's try when the bird weighs 40 grams, its weight is increasing at 60 grams per day compared to 6 grams per day when it weighs 70 grams. And so I'll go back up here and answer the question and say when it weighs 40 grams because. Good enough. Part B. Find the second derivative in terms of b. All right. So notice something here. We're going to take the derivative of this, and we want the second derivative with respect to t, but I don't have any t's in the problem. So that simply means I need to do implicit differentiation. So the derivative of the, actually I guess we read it like that. So the derivative of b, the second derivative of b, is equal to, and now we just do implicit differentiation. You can distribute the 1/5 before you do it if you want, or we can just do it as a constant multiple and realize it's going to be 1/5 times the derivative of 100 minus b is going to be -1 dB dt. And maybe for some of you that'd be easier to see. So let's rewrite this as 1/5 times 100 is 20 minus 1/5 b. So the derivative of 20 is 0. the derivative of negative 1/5 b would be negative 1/5 dB dt, which is what I have, just not simplified out yet. Okay, so we've done a pretty good job, but if we stop there, we will not have the right answer, because it says find the second derivative, but put it in terms of b. So we found that the second derivative equals negative 1/5 of dB dt. Well, if you look back up here, dB dt is given to us by this. So I could ultimately write my answer as negative 1/5 of dB dt, which is 1/5 of 100 minus b. In other words, the answer is negative 1/25 100 minus b. Okay, so find the second derivative, done. Explain why the graph of b cannot resemble the following graph. So there's a picture supposedly of b, but they're saying it can't be. So let's figure out what's going on. They asked me to use the second derivative to explain. So the second derivative talks about concavity. So let's analyze the concavity here. It looks like up until about this point, I'm concave up, and then I'm concave down. So that would mean that my second derivative should be positive at the beginning of this, and then negative later on. So let's see what happens. If I plug in a number like 1 or even 0, you can clearly see I get a negative for a second derivative. So that means my graph actually starts off concave down, not concave up. So I just need to say something to that effect. So the graph in the picture shows concavity or concave up at let's say when t is small, but my second derivative would be concave down. And maybe since they want us to reference the second derivative, I mean, maybe saying it's okay, but maybe we should say my second derivative and then put the second derivative here. And maybe walk them through what we talked about earlier as an example. As an example, and then you could just show that it's negative. And I think would be good. And that may be overkill, and maybe that's something you do only if you have enough time. And then part C says use separation of variables to solve for y. So I need to write the equation down here. 1/5 100 minus b. So dB dt equals 1/5 of 100, minus, and I've lost 100 minus b. And it might again be easier to distribute the 1/5. I'm going to leave it alone and just take it from here. So what am I going to do? I'm going to divide by the factor that includes the b. I could move the 1/5 over as well if I want, or leave it behind. It really won't matter. So I'm going to separate it out, and I'm going to get 1 over 100 minus b dB equals 1/5 of a dt. So when I separate this out, we can hopefully see that I'm going to get a natural log of the absolute value of 100 minus b equals 1/5 t plus a constant. And they tell me b is 0, c is, or when time is 0, b is 20. So I plug in and I get c equals natural log of, plug in 20 for b, and I get 80. The absolute values are not necessary in this case because it's a positive number, but there's my constant. So now let's go solve it. So I get the natural log, and again I can dump the absolute values at this point, equals 1/5 t plus ln of 80. So now I'm going to exponentiate. So I get 100 minus b equals e to the 1/5 t plus ln of 80, which I can write as, again, we talked about this in class, I've got e to a power that includes an addition, that includes a sum. And if we review exponent rules, we know that something like x squared times x cubed equals x to the 2 plus 3. So what we need to do is go backwards, because I have a sum. So that means I could write it as e to the 1/5 t times e to the natural log of 80, and e to that is just 80. So I now have 100 minus b equals 80 e to the 1/5 t, and I now just need to continue to solve for b, and so I get negative 100 plus 80 e to the 1/5 t, or b equals 100 plus, minus 80 to the e 1/5 t. Okay, that should be my answer, but I did dump the absolute values, and I did it because of this 80 was positive, but it occurs to me maybe I shouldn't have done that here, except if we think about it, well, as b gets larger, this will go negative. And so if b ever gets bigger than 20, let's go back and look at the question here, and b is the weight. So there is a chance that b could get over 20, because in fact here it's talking about when it's 40. Then I guess I could have an issue here. So maybe I do need absolute values. And one kind of nice easy way to check it would be I could plug in the initial value they gave me and make sure that it works in my equation. So I'm going to plug in 0, and I get e to the 0 is 1, I get 100 minus 80 is 20. So that is correct. If I had done this and kept the absolute values, then I would also have a problem where all of this was negative, and it may or may not work out. So either way, I'm not going to take the time to check it, because we have an answer that seems to work fine. So let's see how we did. Here's a scoring guide. I know we haven't looked at the score yet, but I have it in front of me here. The average score was 2.87. Okay. So now let's find out how we did. I'm going to find the scoring guide. Here it is. All right. So we got 12 and we got 6, and we said since it was greater at the beginning, the bird's gaining weight faster. We found the second derivative, doing exactly the same math, and we got the right answer. The graph is concave down from 20 to 100. Okay, so they got a little bit more specific than I did. The portion of the graph is concave up. Okay, so I think we got that, but weren't quite as specific. And then they did the separation of variables. They did the absolute value. B is between 20 and 100, and therefore when B is between 20 and 100, we're not going to have any problems with, I'm not sure where the 100 came from, but I'm going to, maybe they gave it to us up in the question. And so I looked through and I solved for B and did everything what they did, and I have 100 minus 80 e to the, okay, exactly the same thing we got. You got 5 points over here. It's going to beep, sorry. 5 points. 1 for separating the variables. 1 for finding the antiderivatives. 1 for figuring out the constant. Actually, so take a look at this. 1 for writing plus c. 1 using the initial condition to find c. Or maybe they're talking about to justify which side of the absolute value, but I think it just means solving for c. And then the last one is finding b. Okay, so there you go. 2 points for part A, 2 for part B, 5 for part C.